Hello and welcome to Chapter 1, a modern view of the universe out of the Essential Cosmic Perspectives book. I'm going to take a few minutes to go over some highlights of this chapter. We're going to start with the scale of the universe. Where is our place in the universe and how big is our universe will be some of the goals for this section. So we want to ask ourselves, where are we in the universe? What's our cosmic address? And so we live on the planet Earth, and Earth is part of 8 planets that make up the solar system, maybe soon 9 if we vote Pluto back into the group. And then the solar system is part of the Milky Way Galaxy, which has 200 billion stars, and our star is just an average star on one of the arms. And then the Milky Way Galaxy is part of the local group of a couple dozen galaxies with 200 billion stars each. And that local group is part of a local supercluster. And this contains billions of galaxies in strings. And then, of course, that local supercluster is just part of billions of other local superclusters in the entire universe. So now let's make some definitions to get us started in this chapter. A star is a large glowing ball of gas that generates heat and light through nuclear fusion in its core. Planets are moderately large objects that orbit a star. It shines by reflected light, does not give off its own light. And the planets may be rocky, icy, or gaseous in composition. For example, Mars is a rocky planet, and Uranus is a gas giant planet. Moons, or otherwise known as satellites, are objects that orbit a planet. Here we see Ganymede, a moon that orbits Jupiter. Asteroids are smaller, and these are relatively small and rocky objects that orbit a star. We find most asteroids out between Mars and Jupiter in the asteroid belt. Comets are beautiful to look at and one of my favorite things to photograph. Relatively small and an icy object that orbits a star, but could have tails that last for millions and millions of miles. And so a star system can be a star and all the material that orbits it, including its planets and its moons. Nebulas is Greek for cloud. And so a nebula is an interstellar cloud of gas and or dust. And then the galaxies are great islands of stars in space, all held together by gravity and orbiting a common center. Usually that common center is a black hole. We know we have one black hole in the Milky Way, and this picture is of the Great Andromeda Galaxy, which is kind of our next door neighbor, and it has 2 black holes in its center. So the universe is the sum total of all matter and energy, that is, everything within and between all galaxies. Now let's take another look at looking back in time. As we look into the universe, we are kind of star time travelers, and we look back in time. We know that light travels at a finite speed, 300,000 kilometers per second. So when we look at the moon, it's 1 second of light travel time away. That means that when you look at the moon, that's how it looked 1 second ago. It took that long for that light to get here. The sun is 8 minutes. 8 minutes ago, that light left the sun and just now reached us. The Andromeda Galaxy that we just looked at is 2.5 million light years away. So that light from that galaxy has been traveling through space at the speed of light for 2.5 million years and just now is getting back to us. So when we see objects as they were in the past, the farther away we look in distance, the further back we look in time. Pretty neat, I think. So for an example, this photo shows the Andromeda Galaxy as it looked about 500,000 years ago. So when will we be able to see what it looks like now? The answer is about 500,000 years. So the definition of a light year is not time, its distance. It's the distance light can travel in 1 year, which is about 6 trillion miles. That's a long way. And so at great distances we can see objects as they were when the universe was much younger. Can we see the entire universe? The answer is simply no. Let me go back to one slide here. The whole universe is about 13.7 billion light years old. The last 300,000 light years of the universe back here at the very edge of the universe is opaque. We can't see through it. So can we see the entire universe? No, but we can see most of it. Well, how big is our galaxy, the Milky Way? The Milky Way has about 100, 200 billion stars. You know, we get grad students to count that kind of thing. That's a joke. On the scale of 1 to 10 billion scale. How big is the universe? Well, the Milky Way is one of about 100 billion galaxies. And again, we get grad students to count those too. So, we've got some numbers here in scientific notation. I'm not going to go over that in case you're not familiar with that. But basically, here's a verbal sum of the universe. It has as many stars as grains of dry sand on all of the Earth's beaches. That's a lot. So what have we learned here? How is the Earth moving in our solar system? It rotates on an axis once a day and orbits the Sun at a distance of 1 astronomical unit. 150 million kilometers or 93 million miles. 1 AU is defined as the average distance between the Sun and the Earth, and it's a cornerstone measuring tool we use for the solar system. Stars in the local neighborhood move randomly relative to one another and orbit the center of the Milky Way in about 230 million years. The galaxies beyond the local group are moving away from us with the expansion of the universe. That's something that Edwin Hubble, a Marshfield, Missouri native born in 1889, discovered. The more distant they are, the faster they're moving.